Okay, this is just a quick example of using bond dissociation energies to calculate reaction enthalpies. So this is the reaction that we've been given, and we want to determine the sign and magnitude of delta H for the following reaction, and then determine whether it's exothermic or endothermic based on that data. So we're going to use bond dissociation energies, and I think it's probably helpful to, rather than using the bond line structure, to actually draw this out and this out as the condensed structural formulas. It makes it a little bit easier to see what bonds we're making and breaking. So I have this propane. Right, and I might have written this as CH2, but as you're going to see, it's this bond that I'm going to break. So that's why I wrote it that way. Right, and then we're reacting that with Br2. And then these are our products. Right, so we need to identify what bonds are being broken. Right, so we're replacing this proton with the bromine, right? So we've got to break this bond, right? And then we're breaking the bond in the Br2, and then we're making this new bond, and we're making this new bond. So we need to go to our chart of bond energies to and see what the values of each of these bonds are. Okay, this may be kind of small in the video, but if you can't see it, right, go to the... You should have the data packet with all the different tables, and this table should be in there. And so we want to write down all of the bonds that we need. So we need to find each one of these. And so if I look down here, right, so this looks like the CH bond that I'm breaking, right? And so when X is H, and I'm going to work in kilocalories per mole, so I'm going to use the column of numbers on the right. If you want to do kilojoules per mole, then you would use the numbers on the left. But if I'm going to use kcals per mole, right, so I need to write down that this bond is 95 kilocalories per mole. And we need to make that bond with the bromine, so I need to write down 68 kilocalories per mole for that. And then I need to break my Br2. So if we go down, so here's my Br2, so I need to write down that number, and then I'm going to make the HBr, so I need that number. All right, so let's go to the next slide where I've got all these written down. All right, so these should be the same as the numbers we had before, so I've got 95 kcals per mole for this CH bond, 46 kcals per mole for breaking the Br2, and then 68 kcals per mole for making this carbon-bromine bond, and then making the HBr is 88. All right, now for these two bonds that I'm breaking, right, breaking bonds is an endothermic process. So I have to put these amounts of energies in order to break these bonds. And so they're going to go in, when I add all these up, as positive. Now, making bonds is an exothermic process. And so when I make these bonds, it's going to give off this energy. And so I'm going to make these guys negative. Right? And so then once I have the numbers and I've assigned the signs as being either positive or negative, now all I have to do is just add them all up. And so 95 plus 46 minus 68 minus 88 is going to give me minus 15 kilocalories per mole. So delta H is negative. It's negative 15. And because it's negative, I know this reaction overall is going to give off heat, and it is exothermic.